I appreciate it, Ron. So my name's John Cronkite. As Ron mentioned, I work here at Logicworks. I'm a primary solutions architect. And so my job is around working directly with clients to figure out their needs and go from sort of a requirements gathering all the way through to building what is needed within the cloud platform. Now, I'm kind of going from a little different endpoint perspective of we kind of look at endpoint as a whole bunch of different pieces. So as some of the others have mentioned, there are a lot of different definitions of what an endpoint is. So I'll go through a little introduction of what who we are, what we do, sort of define what endpoints are, what we're looking at. How do we protect an endpoint? Some of the high risks that we see around just configurations that people may not be thinking of in the big picture. And then how do we improve our outlook? And what about the user side of that endpoint? So with that, let's move in. So who are we from a Logicworks perspective? We're a managed service provider and a professional services team that look at cloud strategy, assessments, optimization, working to figure out what that next evolution of your business is, or how do you maintain operations of a business that you need some assistance to get to a 24/7 operational state within the cloud. So we got a whole bunch of different pieces as that. We got some clients up there that we've worked with, but the biggest thing is there's the cloud approach of getting you in, and then you have to still manage that stuff. If it's a data center on premise, yeah, you have to manage physically. You have to be physically there. When it's AWS or Azure or Google Cloud, you have to have someone monitoring those resources that you've spun up within their facility. And so Logicworks Managed Services rides around that corner to help you have that 24/7 NOC support, as well as the subject matter experts on those different services. One of the things we specialize in is again, the security side of it. So we help people build the foundational security into their environment. So coming on board, if you have a high trust requirement, HIPAA compliance, PCI standards, these are all pieces that we help look at from the ground up. So if you're looking at the high trust, just every control that's required, it can be a daunting experience and takes a long time to get through and make sure you're high trust compliant. But if you don't think about that before you're deploying your core infrastructure, it takes more time to retrofit what you've deployed rather than going up front. So I love this next quote from Dan Farmer. If security were all that mattered, computers would never be turned on, let alone hooked up to a network that literally millions of potential intruders. So realistically, we have this balancing act of, yes, we do want the value add of having our customers, our end users access our websites, our mobile apps nonstop, because it's the best way for our business to improve value or help our end users or the students that are connecting. They need the ability to do what they want to do to help our businesses grow. But because of that, we have to do a trade-off and understand what are the security vulnerabilities, what happens when something happens, how do we know that when someone broke in, what happened? So I'm looking at beyond just the endpoint and what the endpoints are, and how do we protect the whole stack. So in this slide, you'll see just sort of a list of some of the endpoints you might be thinking of. So we got your laptop, the end user environment that someone's coming in, whether it's corporate provided, it's a student at a university that's bringing their laptop in, and then they're connecting to your network. There's a standard, the smartphones are everywhere. IoT devices that you don't even know exist within your facility. And then just the standard, the server room, the part where we take a bigger look at and have more functional approaches to looking at the environment. So what do we need for each of these endpoints? It's like desktop security, traditionally antivirus, anti-malware, when you can control the environment. What happens when you don't have full access or full control from like an end user perspective from a smartphone? You then have to harden your endpoints, so that cloud edge and the other pieces. So just looking at it from a big perspective of, we have many different endpoint devices, having to look at it from the client perspective, your internal perspective, and how you can harden each of those. And then from the Logicworks side, we more focus on the server or the within the AWS, GCP, Azure facilities, and how we can harden the endpoints that you guys have available for your end users. Again, the James Scott has a great quote as well. There's no silver bullet for cybersecurity. A layered defense is the only viable defense. So looking at that, you have the traditional antivirus, web protection. But what do you do from a user and access control perspective within your application? Do you have MFA devices on your machines? Are you using something like what Dylan was mentioning earlier, Darktrace, where you're actually monitoring networking traffic live? From SUSE perspective, are you have Rancher enabled so you can actually see what users are doing what, who has access to each of the Kubernetes stacks across your entire environment? Are you actually performing updates on your systems? I mean, it's not uncommon to see Windows 2008 and legacy operating systems still in many environments. But because of that, what controls do you have in place that you can continue to protect those and a plan to move off of them? So that's just kind of the baseline there of the different ways we've looked at protecting them. And then just some of the security pieces that we see more than we would like to admit. Flat networks in general, with no NACL or security controls between networking devices. So you have this huge layer of you're trusting the operating system for your controls. Publicly accessible servers. This is on-premise, online, in a public cloud or locally. We see a lot of servers that just the traditional configuration is, oh, I'm building a server, I want to access it. And there's limited or no thought on the DevOps security side. And whether that's our fault, it could be. We're talking about these low code environments, like John had just mentioned, of these low code environments are great value add that can get you running really well. But just as John Sullivan, said, is it requires some controls and you have to put them in a box of some kind to limit what can be done. So if you don't provide them the guidance or the control to tell what is acceptable, you're putting yourself and the company at risk. Other piece of shared credentials. See this all the time. And it just needs to get removed from the environments or having a strong pattern of rotation. Unencrypted data, again, sensitive unencrypted data, not just unencrypted data, is found all the time on a local system. Someone exports something to view what's going on and then leaves it there, not thinking about it. And then the last two are just ones that are like, the biggest issues you find is a breach happens and you don't know what happened, or you say something broke, what changed from then to now? So those ones are just pieces that if you don't know what happened, it's hard to fix or prevent in the future. So what does that mean from my perspective? Is I like to look at it as like a layer of an onion, and there's always another layer. You'll always find a bigger onion. But if we can keep providing the foundational guardrails and continue to apply security at a holistic approach, we can prevent as well as remediate when things happen. So specifically within an AWS environment, there's this construct called control tower, and it's a centralized management layer that allows you to manage an environment that has multiple accounts, organizational structures in a secure and infrastructure as code manner. So the pieces here that you'll see on the screen are some of those core fundamental components that allow you to have logging available, so you always know what happened. Monitoring of systems that are there, not just that you migrated your systems into AWS, but now you're able to see what alerts are coming through. Are you actually having a system that has high CPU? Is there an outage on the API layer of an HTTP REST request? You can go from the basics that you would expect from RAM, CPU, all the way through layer 7 stacks. But again, each of these are required from a security perspective as well. If you don't have logging enabled, you don't have traceability to understand why something broke or why something was changed. It is in a non-secure environment, it's not uncommon for an access key or secret credential to be accessed in the environment, and a malicious user to spin up tons of resources. If you don't have the traceability to understand what they did, you cannot ever confirm that you've removed everything from the environment, and you're looking at it as almost an infected environment until you destroy everything and start from scratch. So this is just one of those key things. And on the screen, I'm scratching the surface, but giving you an idea of all the different components that are available from AWS, as well as some other cloud providers, of how you can use these. Now, this isn't to mention that you can't integrate these items back into third-party services you already have. So Splunk for a SIEM, log analytics that you take the raw data and push it up to something that you guys already use today. The key is having the information available to you so you can have a secure and reliable cloud. So then the next piece we're looking at here, back into the layered perspective. I just talked about sort of the foundational, the wrapping, the logging, the monitoring that comes in it. Then you need to understand, what is your application traffic flows? How is data coming in and out? Is your application able to be deployed in a risk-bound scenario? So if you're developers and you want them to be as active as possible and be able to test iterative changes with a CI/CD pipelines integrating into an actual application stack that they can test, but you don't want them to take down production at the same time. So how do you create the mechanisms to split out production, non-production, give them access to, on this right-hand side, a centralized workspace that can be secure, have all the everything that they need to be able to access the environment in a potentially PCI compliant way. The key here from a endpoint security perspective is the endpoints are accessing directly in. So you have that traceability of who's coming in, who's going out. You have the networking constructs of a transit gateway, which allows isolation of network traffic between different subsets of data. And then the last slide here of just sort of a design perspective is just, you have to teach your developers, your DevSecOps, anyone that's using the environment, how to use it. If I throw them the best designed environment out there to every single one of the AWS best practices, the first thing they're going to do is try to spin up a server in a public subnet with a public IP that they can access from home. If you don't set the guardrails to the user experience, as well as have the foundations in place from the AWS or the cloud platform, you're still going to, your best kept design can go amiss, which again comes back to the guardrails we talked about at the very beginning. Was if you have it so that someone cannot create a public instance, or you are logging and monitoring on an instance that is created that is publicly accessible, you then have alerting and mechanisms to remediate that issue before it becomes an actual incident. So sort of moving forward off of that, it doesn't stop with just getting the stuff in place, training your teams, but when you're getting into any platform, whether that is on-premise, whether it's in the cloud, you need the ability to operate efficiently, as well as have support when you need it. One of the things Logicworks does, again, is having a 24/7 support team. We do monitoring patches, incident response, alerting, as well as a large set of platform tooling that we've integrated with AWS and Azure to allow that automation and that insight and visibility. So with that, I think I'm at the end of my time. So let me see if I got any questions, or Ron, before I hand it back over.
Maybe you could touch on when people are using Logicworks. Ted raised this question, our great responder, before we turn it over to AWS. It's hard to say, but when people move to the cloud with Logicworks, so they're saving 5%, 10%, or it really just varies based on the situation. These are good questions, Ted, but it's hard to create a standard answer because I'm sure it just depends on each individual situation.
Yeah, and that's exactly right. And I'll tell you the one thing I'll always tell any client I'm working with is, let's look at your estate and see what makes sense. Anytime you move stuff like for like into the cloud without actually looking at your architecture, dependencies, and other pieces, you may be moving it into a scenario where you have less performance, you might have higher costs. So reviewing the whole ecosystem that you have, pinpointing what you want to do, and then seeing how we can align those business objectives and goals to a reality in the cloud. And some of that might be like a no-code, low-code solution. Some of it might be a move SAP onto SUSE into the cloud. So it's very client-specific, and those discussions are really good to have up front before you try to move. And then 6 months later, you say, why is my cost X or why is it slower?